On Mind Over Math, we're going to talk about the right triangle and the Pythagorean Theorem, c squared equals a squared plus b squared. So one of the things that we want to talk about is the right triangle. The hypotenuse C is always opposite to the right angle of the right triangle. Pythagorean theorem does not apply to other types of triangles like obtuse and acute, only to right triangles. Pythagorean theorem is used when you know two sides of the triangle, any two of the right triangle, and you want to find a third. It doesn't work when you know angles. You'll also notice generally in trigonometry, capital letters A, B, C, or could be D, E, F, are used on the vertices, and the sides opposite to those are lowercase letters like A, B, and C. Now, A always sticks with capital A and so forth. And then one more thing, the Pythagorean theorem always includes the hypotenuse over here. It's not just any side you would like. Then these are actually called legs. The non-hypotenuse are the legs or the sides. The hypotenuse will always be the longest side. There is no choice on a right triangle there. So an example would be a sides 3 and 4 type of triangle. So we would plug the A's and B's, 3 and 4, into the Pythagorean theorem, and we would get c squared equals 25. And to solve for C, we have to reverse squaring, which means square root, and the square root of 25 is both plus or minus 5. Now, in our particular illustration, it's not possible to have a side which has a negative length. So we would eliminate that, and most of us don't think about that, but there actually are two square roots of 25. Negative 5 times negative 5 does give you 25. This particular problem is called a Pythagorean triple because all the sides end up coming out exactly as whole numbers. They don't have to worry about decimals or radicals, as we will later discuss. Most triangles do. So this is a 3, 4, 5 Pythagorean triple. Here's another Pythagorean triple. We'll find out. 6 and 8. In fact, that's double 3 and 4 on the last problem. Again, using the Pythagorean theorem, we will find that c squared is equal to 6 squared plus 8 squared, which adds up to 100. The reverse of squaring c is to reverse it and square root it. The square root of 100 is the perfect 10. Where's a Pythagorean triple used? Well, it's used in construction. It's actually a great aid. If you know how to use it, it's really quick. Take a 3, 4, 5. If I went into a room and wanted to know if the angle there was a perfect right, let's say I'm setting the walls of a room or beginning a house, then I could take my ruler and measure 3 feet over from the corner and 4 feet from the same corner on the other wall. If this is a perfect right, then according to the Pythagorean theorem, this would be exactly 5 feet, not 4 feet 11, not 5 feet 1. That would tell me this corner is a perfect right. Now I could do the same thing on the other corner, or any corner I wanted. I could do a 6 and an 8. Now that's the one on this page. A 6 and an 8. Then to check this corner to make sure it's a perfect 90, this would have to be exactly 10 feet or 10 yards or 10 inches, whatever units I'm in. How about a 5 and a 12 right triangle? Well, once again, when I plug them into the Pythagorean theorem, 12 squared is 144 and 5 squared is 25. those add up to 169. And reversing the square of c squared, I square root both sides, and I get 13. So now I find out this is a Pythagorean triple. So once again, not only could I do a 3, 4, 5 right triangle in my determining of a rectangular room, I could use 6, 8, 10, but I could also use 5 feet, 12 feet, 13 feet. Any of them would be adequate. Probably the bigger measurement would be more accurate if you're setting a long wall. Now, we're not always trying to find the hypotenuse. Sometimes we know the hypotenuse and are missing a leg. So in this case, I know the hypotenuse is 10. So I square it. On the other side of the equal sign is side A is 3. And good algebra tells us that I have to keep the equation and solve it for B. So to do that, I have to move the 9 across by reversing it or inversing it. I subtract 9. And I end up with B squared equals 91. But in order to find B, I must reverse the square. So when I reverse the square, I square root. Now let's say you don't have a calculator. Could you get pretty close? Yeah, you could get really close. How do you do that? Well, here's an example of this problem. Square root of 91. I don't know what that is. But if I do know that square root of 81, 81 was just below 91 and it was 9. And 100 is a perfect square root of 10. And I could kind of look at these and go, you know, there's 10 difference there and 9 from there. So this is probably about 9.5. You could get the answer pretty close without a calculator. But most of us have phone calculators, or we have regular calculators, scientific calculators. So 9.54. So just a little bookkeeping here. If you were in an algebra class, you would often get answers like c squared equals 12. And as you square rooted it, you would see square root of 12 is not a perfect square root. Well, at that point, you would want to break it down into 4 times 3, because 4 has a perfect square root. Now, you could use 2 times 6, but it's not going to get you anywhere, because neither of those is perfect squares. So when I look at this, I see this square root of 4, and I know that that is 2. So I pop out the square root of 4, which is 2, and the radical 3, I can't do anything with that. That's a irrational number. So once again, in algebra, this is a way you would bring your answers in. This is called simplifying radicals. So here, let's say we came out with not 12, but we came out with 24. So if I square root 24, I'm going to break it into the factors 4 times 6. Now I could do 8 times 3, or 2 times 12, but none of those are perfect squares like 4 is. So the square root of 4 is 2. So that square root of 4 pops out as a 2. 2 square root of 6. And I won't go through all the details, but we could get numbers larger like 48. The square root of 48, wow, there's a lot of factors of 48 that we could use, but I'm going to pick 16 times 3. You go, well, that's not a very common factor set. Well, that's the largest factor set. You could use 4 times 12, but you're going to be doing this problem a few times. So by practice, I know 16 times 3 is 48, and the square root of 16 is 4 radical 3. Now, if you pick 4 and 12, you're going to have to break 12 down. You'll do this in 2 steps. I did it in 1. The less steps, the less errors you have. More practice, you get used to doing these. If you're not doing them a lot, you're never going to, develop shortcuts if you're in a business that requires that. So review. Here's our main ideas for the right triangle. The hypotenuse is opposite to the right. Pythagorean theorem's used when you know two sides. How to label a triangle. The Pythagorean theorem is the hypotenuse on one side, it is the longest side. And the Pythagorean triples. So this is a summary. If you would like to screenshot this, this would give you a good idea of what was in the entire presentation. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.